In this problem, we're going to look at graphing some ramp functions and some rectangle functions. And one of them also has a unit step function thrown in there as well. So what a ramp function is basically just the line y equals x. So it's just slope upward. And then if you put a number in front of it, then that increases the slope. So, for example, if we look at a, when you see that 5 in front of the ramp function, that means you're going to have a slope of 5. And when you see the negative 5, that means you're going to have a slope of negative 5. And just like we did on problem 1, we're going to start left from right, but this time we are drawing the graph rather than coming up with what the function is. So we start with our axes, and we can see that up until -2, our function is 0, so it's 0 up until -2. And then when we get to -2, we have a ramp function that has a slope of 5. So that means for every 1 in the x direction, or every 1 in the t direction, so this is t and this is v. For every 1 in the t direction, it goes up 5 in the v direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I get to -1, I've gone up 5. 1, 2, 3, 4, 5. And when I get to 0, I've gone up 10. So I have a line like that that has a slope of 5. Now, when I get to 0, I have the -5. So what that does is it subtracts 5 from the slope. So I had a slope of +5, and now I'm subtracting 5 from it, so now I have a slope of 0. So now the graph looks like that. Let's show you again. Okay, so now let's take a look. I'm going to see if I can be all fancy here with my straight lines. Fancy straight lines. Okay, so now this one, it starts the same way. We have a ramp function that starts at -2. So before -2, it's 0. At -2, so the places where we have a change are -2 and 0 and another one at 0. So before, well, let's go ahead and do what happens at -2. At -2, I have a slope of 5. So I go over 1, up 5, over 1, up 5. So just like on the one before. So I'll just mark this as 5 and this is 10. So when I get to -1, I've gotten to 5. When I get to 0, I'm at 10. So it goes up like that. But then what happens is I have -5 on the ramp function. So my slope was +5. Now I'm subtracting 5. This is my slope. So my slope is now 0. So now I'm at a horizontal line. But also I have -10 of a unit step function. Well, -10 of a unit step function, that just brings me down 10. So I go down 10, and then I have a horizontal slope. Okay, so now on to C. Okay, so for C, I have just a plain 10. That means that I'm starting from a height of 10 in my voltage, so I'm starting from a voltage of 10 rather than from the 0 axis. So let's see, and then I have changes at -2 and 0. So up until -2, I'm at 10. And then I have a slope of -5. So for every 1 in the t direction, I go down 5 in the v direction. So in this time, I'm going to go down to 0 by the time I get to 0, because I go down 5 at -1 and then down 5 more at 0. So I had a slope of -5. Now I'm adding a slope of 5. So now I have a slope of 0. So I go on in that direction. Okay, so now on to the rectangle function. And I will be honest with you, I don't believe I've ever seen this outside of this class used this way. Instead, it's been given in terms of unit step functions, because you can write these with unit step functions. I wonder what I just did there. Okay, so you can write these, have a nice little extra line right there. You can write these with unit step functions as well. So the number in front tells you how high the rectangle is. The number on top tells you where it's centered. So this one is centered at -1. This one is centered at +3. The number in the denominator tells you how wide it is. So this one has a width of 2. And this one also has a width of 2. So if it's centered at -1 and it has a width of 2, then that means it goes to the right to -2, to the left -2, and to the right 0, and it has a height of 10. Now this one over here is at +3. It also has a width of 2. So that means it goes to the right to 4 and to the left of 2. You see now it has a width of 2 and it goes up to 10. Wow, my 10s are very different on my two scales. Okay, so now let's draw this over here. Let's make this 5 and 10 and -1, -2, -3, -4, 1, 2, 3, 4, 5. So at -1, I have a rectangle of height 10 and width 2. So height 10 and width 2. So it looks like that. And centered at 3, I have a rectangle of height 10 and width 2. So it looks like that. And it's 0 everywhere else. Okay, and then our last one. So this one is centered at +1. This one's centered at +3. This one has a height of 5. This one has a height of -5, and they both have widths of 2. So before I do that, let's think about this. If it's centered at 1 and has a width of 2, that means it goes to 2 on the right and 0 on the left, and that'll give us a width of 2. If it's centered at 3, it'll be just like this one up here. It'll go 4 to the right and 2 to the left. So let's see. Yeah, okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So centered is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we have negatives here too. It's -5. So centered at +1 and a width of 2 and a height of +5. Centered at 1, so it goes down to 2. Okay, and then centered at 3, and it has a height of -5, so that means it goes from 2 to 4, so it looks like this, like that, and then 0 elsewhere.